All right, so let's get started. My name is Krzysztof Cwalina. I'm a program manager on the CLR team. I'm one of the original members of the .NET Framework team. I designed a couple of libraries. And recently, I spent some time thinking about kind of the mistakes that we made in the framework related to usability. So the goal of the framework libraries was to produce a set of libraries that are both powerful and easy to use. And in a lot of places, we succeeded. In some, we failed. And kind of this lesson is compilation of the findings that we did after as a post-mortem. So we're going to be talking about designing APIs, as I said, that are both easy to use and powerful. I know Steven was talking about developer personas a bit, but I think Anders Hejlsberg says that the biggest problem with personas is that everybody understands them differently. So maybe one more reminder will not hurt. And then I'm going to describe kind of a process, a simple process that we develop for designing such powerful and usable APIs. And we call this process development of progressive APIs. So let's quickly, maybe I'll just go through kind of the most important aspects of each of the personas from kind of my personal opinion, maybe. So Mort, I would say that the most important thing to remember about Mort is that they are developing very vertical applications. They are not developing, they are not using the whole breadth of the platform. They are writing very specific apps. So in, it's either WinForms or ASP.NET app that basically shows a form, maybe displays some data from a database, asks the user for input, and saves the data into a file or a database. This is very narrow scenario. Therefore, and VB6 kind of succeeded in this space, providing APIs for such vertical scenarios by saying, hey, this is the most common scenario. We will optimize for these common scenarios. If you want to do something more advanced, you will have to go through a lot of hoops. And another important thing is that Mort likes to learn by using the APIs. They don't want to read a lot of books. They don't want to study the technology. They don't want to understand what this technology can potentially do for them. They just want to do this usually very common thing in given space. So now Elvis, we call them pragmatic developer. They are very skilled developers. They understand programming concepts very well, but they seek this balance of power and productivity. So they are very happy with us adding very advanced features to the platform, but on the other hand, they are looking for these helpers. They appreciate designers. They like working in tools, in Visual Studio. Maybe you've seen some of the features that C# team started to add in Whitby, like the refactoring features in C#. This is something what Elvis really appreciates. And that's kind of also the main difference from Einstein, who is not really concerned with a lot of helper methods and productivity on top of existing APIs. What Einstein really wants is true transparency of APIs. They want to, even if we provide a helper, Einstein really needs to know what's happening inside the helper method. They also really like pluggability, where they can replace every single functionality that we don't get right. And they get, one important thing is that they really value elegance in APIs. So there are some, in some common scenarios, you will see a trade-off between, hey, it can be done it can be productive, it can be easy to use, it lends itself to, IntelliSense, but it's not that elegant. And here's, a compromise that sometimes you will have to make when you design APIs. And their learning style is proactive. So they do spend a lot of time reading books and trying to understand the breadth of the technology before they start using it. And I don't know if Steven was mentioning, but that's a problem in usability studies of when we get Einsteins to the lab, they often spend 45 minutes reading documentation and only 5 minutes actually using the product. So what is the progressive API? In the VB6 and Visual Studio 6 timeframe, we had different frameworks for different developer groups. So we had VB6 Ruby framework that was optimized for this very vertical scenario, and it was very easy to use. But once you wanted to develop some more advanced application, it was getting difficult. And at some point, you were hitting what we call a wall, where you basically had to switch the technology. Now, MFC or ATL were different framework targeted at probably Elvis's or Einstein's, and they were very powerful, but the barrier to entry was very high. So you could reasonably well program in VB6 by just, hey, I bought this VB6 box, I installed it on my machine, and I started to experiment. That was not the case for ATL or MFC. So progressive API is an API that says, we're not going to have two separate frameworks. We're going to have one, and it's going to have low barrier to entry, and then it's going to get progressively more difficult. You're not going to ever get, powerful API and very usable API. It's possible to develop single framework that has both of these. Is both powerful and usable, but it's kind of progressive. It gets harder and harder as you get to more advanced scenarios. So this is kind of what I was talking about, the VB6 timeframe and VB6, VS6 timeframe, where we had two different frameworks. You could start developing more and more advanced applications, but at some point you said, hey, it's better to just switch to MFC. VB is probably not good for my scenario. And that's what we are trying to do with the .NET framework. It gets progressively more difficult, but it's progressive. You can kind of transfer your knowledge. You can start with the simple scenarios, learn basics, and then progressively learn more and more, and you don't have to switch the environment. So now, I know Steven was talking about kind of, what are the common mistakes in API design, how users react to these mistakes. I'm going to talk about some very rudimentary process for developing usable and powerful APIs. And we developed a set of principles, API design principles. I think the first one is the most important one. So if you remember one thing from this class, I would remember that one. And that is that when you design APIs, you should first start by writing the code that you would like your users to write when they code to your API. So a common mistake is to say, hey, I'm going to just open this Visio or some object modeling tool and design my great object model using some object-oriented methodology, and then I'm done. Okay, this is my API. This principle says, no. You have to do the reverse. You first write the code that you want users to write. So you're designing an API for reading from a file, line by line. What is the best, what is the easiest sample code that you want users to write? Just file.read all lines, correct? After you write those scenarios and those scenario samples, then you say, hey, what is the object model that I need to support these samples? And this is a very powerful technique. Of course, this technique will not result in the full object model that you want to ultimately get, but it will give you the core. It will give you the most important APIs for the most common scenarios, and then rest of the APIs you can add them on top of the core, and they will probably get less and less usable, but if you define the tough scenarios right, you will be covered for the 80% case. And second important part of the scenario-driven design is that you have to actually then usability test the resulting object model. Sometimes the translation from the code samples to your object model may be lossy, so you may miss some important APIs. A good example is usually when you write sample code, you would write them in your language of choice. But then I would recommend that you do the usability study in a different language. We made the mistake of, in system.io namespace, where we didn't have end of file property on stream reader, I think. And the issue was that in C#, you can actually make an assignment and comparison inside the while loop expression. In VB, it's not possible. VB doesn't support such syntax, and therefore the whole object model was basically not usable from VB. So either write the code samples in both languages, or write code samples in one and then usability test in the other one. So the second principle is principle of supporting experimentation. Stephen was talking, and I was talking about more really, learning through experimentation and sitting in front of the machine and trying to poke around the APIs and seeing if something works. And we need to support that. So there are some APIs that are very good for experimentation, and then there are some others that are not. So what makes an API good for experimentation? Obvious entry point is one of the most important factors. So you've seen the usability slide where the user was trying to write to a file, and they go to system.io namespace, and we told them which namespace it is, which is not often the case. They go to the namespace and they search, and it's really not obvious which of these, text reader, stream reader, stream writer, stream, and so on, file stream. And a good way to indicate what is the entry point is to use the domain correspondence principle, which is they want to read from a file, correct? Let's just name it a file. Even if in the pure, object-oriented or pure design sense, the name doesn't match necessarily 100%. One of the recent examples from WinFX reviews was printing APIs. So there was an API for that is basically a proxy to print queue. But as far as users are concerned, they don't care that it's a print queue, okay? It's a printer. They want to print on the printer. Einstein would probably prefer the explicitness of naming it print queue if it binds to a print queue, but Elvis and especially Mort would probably prefer just the simple name that doesn't necessarily match 100% the underlying functionality. Another important factor is minimizing initialization. So the way people experiment with APIs is basically they try to instantiate the object and then just set some properties and call some methods. What they need some feedback. So if they do it and nothing happens, like really nothing happens, they don't know, am I even going in the right direction or not? So for experimentation, they need some feedback. And a good way to get feedback is to require minimum initialization. Like if the only thing that you need to do to experiment with an API is to instantiate it and then every single method actually does something, that's a good way for people to get feedback and experiment. And you can say that console is a great example of such API. The entry point is very obvious, correct? It's console system. It's system namespace, the one that is imported by default. It's called console. Everybody knows it's called console. And then all the methods, they just work, okay? You don't need to do anything to console. You just say console.writeLine, it prints something on the screen. Maybe it's not the color that you want, but that, that can come later. If you don't like the color, you can then, the user can browse the object model, see if there are some properties to change the color or something like that. And usage of properties is very important because properties actually, the idea of properties to communicate, this is something, or especially settable property, this is something where you can tweak the behavior of the object. So, you instantiate it with a default constructor, and then properties are ways of tweaking. And immediate feedback, as I mentioned. And exceptions are a very good way to communicate feedback in cases where you actually cannot do anything with the components. So an example would be a message queue. Message queue has a default constructor, but it requires the path to be set before you can actually send a message to a message queue. So if you don't set the path, we just throw a very clear exception saying, hey, you need to set the path before you can send or receive messages. The third principle is the principle of aggregate component. So that kind of relates to the fact that one of the biggest usability problems is that people cannot find the type that they should start experimenting with. And a lot of people thought about this problem, and there's even a design pattern called, I think, facade, that basically tries to, say, hey, there's some really complicated underlying functionality, and we will expose it through a kind of simple object model on top of it. The difference between facade and aggregate component is that facade usually hides completely the underlying functionality. Secondly, aggregate component adds the concept of create, set, and call usage pattern. This is a pattern that was actually popularized by Visual Studio, where when you program in VB6, users usually would drag a component, drop it on a form. Well, that instantiates an object, and it uses the default constructor. Then they would basically look in the property grid and try to set some properties, and then usually call just simple methods inside some event handlers. Well, but then they would do all of this in Visual Studio, but then would look in the code, and they would see, oh, there's a constructor, instantiate the object and sets the property. So they would learn what it means. They recognize this pattern immediately, and they know what each line of the code does. And even if you program design components that are not integrating with Visual Studio, it's really valuable to provide this kind of simple call set, create call set pattern on your components. And I already mentioned message queue, but the code sample actually shows an example of such design. Oh, and it's important so aggregate components, they usually aggregate functionality. So you could imagine a file where you don't have stream reader and stream writer and another component that will modify ACLs on a file and so on. You just have one component that does all of these things. But then the component actually has modes, correct? It can be open for read or open for write. So it's not aggregate components are not good types to be passed around reusable libraries. So you can imagine I have a reusable method that reads file till it finds some tag. Well, the file component would not be a good type to pass to such method, because then the method would first have to check, is this file open for read or for write? Is it in the right mode? Can I, whatever, append, search, and so on, seek back. Therefore, the factor types, those are the streams, the underlying functionality, they are modeless. They are still exposed from such aggregate components. So you can imagine a user instantiates a file, sets the path, opens it, writes a bunch of operations, and then they want to pass something to a method that will seek to a given tag. Well, they can extract a stream reader from this file and pass it to the method. So aggregate component builds on top of the factor types, and factor types are used to as types that you pass around reusable methods. The principle of self-documenting APIs. So I think Steven spent a lot of time about that, but again, to stress, as you probably, those of you who know the design guidelines, they stress the importance of naming things as, you know, what they mean, and don't use abbreviations and acronyms and so on. And this is kind of, you know, this is the reason why developers really don't mind typing a bunch of, you know, a couple of more characters, but they want the names to be very expressive. Consistency is very important tool for self-documenting APIs. And the principle is, the idea is that if you learn one part of the library, and the second part of the library is very similar and consistent, well, it's self-documenting, correct? It just says, hey, I'm a similar pattern. You don't need to learn how to use me. You can just transfer your knowledge from the other part of the library. I was talking about exception messages, very important, and they should tell users what to do. So instead of saying, hey, you know, you need, the message queue is not specified, tell them, you know, you need to set the path property to the queue that you're trying to send the message to. And the principle of progressive APIs also applies to documentation. So we were saying that, you know, a lot of users, they don't want to read documentation, but often they have to. And when they don't go to documentation, they also want the documentation to be progressive. What it means is it has to start from the with the simple scenarios, with the simple concept. It has to explain what this API is intended for, and then go to more and more kind of advanced concepts, which is not the case in version 1 of the framework API documentation. For example, I don't know if you noticed, but the reference pages, they all start with a short summary. So the summary says, you know, this property name returns name of the whatever, of the type. And then the next section below starts talking about threading. And it says something like, this component is not, you know, thread safe, blah, blah, blah. You have to, you know, use synchronization. And it was one of the problems. Steven was not showing this usability clip, but there was one where the user basically goes to the stream reader documentation, starts reading, and it says something like, you know, this reads characters, blah, 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 and then reads the threading section. And it's like, oh my God, you know, this is not for me. So again, the documentation has to be progressive as well. And keeping things simple. So number of objects, this is also a big problem. For example, before you can use system.data APIs, you need to hook up a bunch of objects. I think you need to like, connection, adapter, data set, and so on and so on. This is a big usability hurdle. So I say that, you know, the number of people that will be using an API is reversely proportional to the number of new statements that you need in your, you know, code sample. And that's really true. I mean, the easy way to get usability is to say, hey, you can do everything with one object, and if it needs to, you know, it will create some additional objects for you if it needs to, but the user basically just says, I want this one, and uses one new statement. And dependencies and configuration. Again, people want to do everything in code. So, you know, they don't want to specify manifest by default. It can be an added feature, okay? It can provide some additional functionality. But by default, no manifest, everything in code. As I said, you know, create, set properties, and call simple methods. Number of code, lines of code, you need to keep a balance here. I mean, not everything should be done with one line of code. But, you know, less lines of code, less mistakes they can make, and less things they need to understand, and less APIs they need to discover. And again, don't use object-oriented design methodologies for design for API design. The methodologies were basically designed for were invented for design of internal implementation that is resilient to changes, or that is easy to change. It was not, the methodologies are not for API design. And I don't think, I was saying this is a rudimentary design, API design methodology, but actually there's not that much research in API design. Not many people do it. There's not that many very big API libraries. Just a handful of companies does that. So to summarize the lesson, I would like to, again, stress the first principle of API design, which is you have to base your design on top scenarios. You have to decide what they are. And secondly, you first have to write the code samples that you want users to write in the top scenarios. Then design your API, not vice versa. And very important thing is to understand your customers. I encourage each one of you to go to at least one session of usability studies and see maybe each of these personas in action. It's really an eye-opening experience. It's easy to design APIs for people like yourself. It's very difficult to design for somebody unlike you, and the usability study can give you some insight into that. So I think that's it for this section, and yeah, I would be happy to answer some questions. No questions?
No questions on API.